Alright, let's take a look at this problem. Find first and the last position of element in sorted array. Okay, given an array integers nums sorted in ascending order, find the starting and end position of a given target value. If target is not found in array -1 you must write an algorithm with log n. Alright, so we are it's actually a good it's actually a hint that I should use a binary search. I should perform a binary search on the array. So for instance, let's look at the examples. So if you're searching for 8, it is there, that is that. If you're searching for 7, then all right, so when we find something, let's think about binary search. So I just start from there. Actually, this is 6 divided by 2 is 3, which starts from here. Then in that case, we might have we should go both sides, right? I should just perform yeah, if I perform binary search, and let's do that. So and then we just go from to right and left at the same time, or it doesn't matter, we just go right and left and count the, or the, like, say which indexes have that target. So yeah, we might also have, can we have something like, if we search for 5 and 6, if I just search for, if I do binary search on 7, 8 and 9, and the positions where I find 9 will be the index that I don't want. So actually I will just test it. So I just need to implement the binary search here, which will be, so I will have left 0 right will be equal to n minus 1 1, and then n will be length of nums. And here I will have a while left is less than right. I will calculate the med, which is left plus the left plus right divided by 2. And if the nums mid is equal to the number that I'm looking for, I'll just what's the target? Yeah, target. Then I will just return, let's say that I will just return or yeah. My first approach was actually not log n, because in that case I have to go from right to left. Let's say that all of them are 8, right? We find 8 and then I have to go left and right. So I just, but it's also of n, right? But I have to find in between starting and ending position. All right, so then I just want to have this. So yeah, so I will have this in a function def binary search. I'll just pass the number, which is the target t, right? So t here, like that. I'll just return the index I'm currently at, and else if nums mid is equal to I'm sorry, actually it is, if it is greater than or equal to, no, less than targets, yeah, greater than or equal to targets, then it means that our mid value, our target is on the left side, so right will be equal to mid minus 1, and else it means that we want to go right side, so it means that mid plus 1. So in that case, when I find it, like after this, I'll just return the left, because let's see, if I don't find it, I'll just return left, and also maybe also it might mean that. So let's go over this one. I'm looking for 9. I come here. Right, where is this? Plus 1 there. Left, right, it is there. Calculate the middle of it. Divide by 1, 0. Our mid is here. It is less than what I want to have. I come here. This is left, mid, right, left. It is, if it is equal, do I want to go in? Yeah, I go in. Then my middle is left, right. It is not there. 1. At that point, what will happen is that my middle is less than my target. Right will be there. Yeah, I will return my left. All right. So now here, I just want to return binary search target. Okay, yeah. I mean, -1 binary search. This will be wrong, but I know that target plus 1. So I'm just gonna test it, but I know that it will be wrong in these cases. But I just wanted to check what's if I have a out of index, and this should be minus. Wait. Yes. Oh, right. Right minus left divided by 2 plus left will be that. All right. So I search for 7, which will return me that. Okay, let me think. So this will always return -1, and this will always return +1, because I don't want that. Right, +1, or, but we might have many of those. But okay, let's see. So if I have like 7, 7, 7, 7, will it be returning the true value? No, because here we find that just so also I should return. So if we find, if we have it, So there are a few cases where we have multiple first. So what will happen if, like, let's say that we find it and then we want to maybe we search for it, and then if it exists, we just search for 7 and 9. Just 1 second. Okay, let's see. So what can we do here? Let me find the ranges between. Maybe if you just go through all of them, but in that case, there might be a problem because say that you only have 7 to start, and you have like 9, 9, 10, 10, 10, 10, 10. Half of n. Maybe my approach is wrong. So I'm searching for, yeah, it's like I'm pretty sure that I have to use a binary search here, but I'm just gonna read the question again. So given an integer array of integers, sorted as in order, find the starting and ending position for given target value. So if I find the previous element and the next element, right? In that case, I have some sort of a range, and that range is, I can just go over that range and see in which position it starts and in which position it actually ends. So 0, 6, 8, 9 is true. Yeah. Can we remove the duplicates there? Duplicates, can I remove or do anything like that? I mean, I can run extra for loop for this problem and find it, but I don't think it will be a log of n. I'm just trying to find a way to, do it in a proper way. Let me think. I mean, the only way to do is to So to find the element just before it is log of n. To find the element just after it will be log of n. And maybe we just start from those sides and go inside. And whenever we see that element, like that would be, yeah, I think like prev will be that. Like I would do it this way. I'm actually not that. I'm not sure like if that's the problem. That might be a problem. The complexity. I mean, next will be that. Actually, this can't be next, but next next target. Target. So what I want to do here is to find the first. So start from that prev. So for every I in range prev target to n and f. So I will have like start equal to 0 and -1 and is equal to -1. If the element in nums I is equal to target, then I just want to return, not return, but start is equal to I and break. And also want to do the same thing, starting from the other side, and for that prev to n, and also prev to actually next target, which will make have it that, let's say that in this case it will be 4 to 6, actually 3 to 5, 9 will be there, 8, 7, 7 and 3. Between those I just want to go in and I want to add to that prev. Actually, yeah, I want to prev plus that equal to target. I also want to have this again. The reverse. So next target, I want to start with. I don't want that. So +1. I don't want that. +1. Doesn't matter. So I'll just start if it is equal to target, and will be that, and I'll just return start and let's see if this works. Yeah, it is working. Let's try a few more cases where if I have 0, I think it should return. Oh. Yep. Yeah, here just before everything, just want the f, the length of nums is, or if not nums, just want to return -1 and -1. And here my target is 6. 6. That run. Wait, if not nums. Well, we should not go in this, right? Why are we going? to there if nums is 0. Oh, but I saw another problem there, which is when this is 0, we have a problem where we search for 0 and right will be also 0, and in that case I just don't want to go there. And also like this, let's see if it works. The complexity here should be, I'm not sure about the case where if we have all of them 8. Actually, yeah, it is log of n. It's log of n. So whenever we see that, I mean, it's just we start from 9. Like if you take a look at this, we look 9, we search for 7. But in the case where we have like 7, 7, 7, 7, all of them 7, and like 1, 9, then it's like almost going for n of them. So that's why I thought it would be a good idea to, you know, to do it like in a different way. Let's take a look at the discussion actually. Pretty green iterative binary search. I'm just going to check it. Okay, it is binary search. I'll take a look at these after later on, yeah. But this is working, and I think it should be log of n. Maybe the worst case scenario is log O of n, but I think it should be log of n. I mean, in the case where I have everything like 1, 8 there, and then 9, 9, 9, 9 there, and like 7, 7, 7, 7 there. In that case, I have to go from right and left. Like I have to go off n divided by 2, which is O of n. So that might be a problem. So that's why, like, I thought maybe it's not optimal way to do it, but I think it should work in all log of n. Yeah, I'm just gonna close it and I'll check if there's anything possible to do better. Then I would probably try that and record another video. All right, I'm just gonna close.